Zod 4 uses an entirely new internal architecture, there's new packages, and it comes with a ton of changes. It's faster, slimmer, more efficient, implements some long requested features, and deprecates a bunch. There's tons to tell you, but I'll try my best to update you in a few minutes. I'll start out with the new package, Zod Mini. This has been made to address a fundamental issue with Zod, tree shaking, which impacts its bundle size. Zod Mini is a sister library with a functional tree shakeable API that corresponds one-to-one with Zod, but where Zod uses method, Zod Mini generally uses wrapper functions. Some things stay the same, like the parse methods, but there's also been a few methods that have been moved to the top level to help with the tree shaking. With this simple code here, switching to Zod Mini is more than a 6 times reduction in bundle size. Now don't panic, you don't need to switch over. The Zod library is still the recommended one, but this is there to provide a nice option for projects with extreme bundle size constraints. The core library itself is now 57% smaller anyways. Moving on, Zod 4 adds so many useful new types, starting with template literals, allowing you to define a type like this, which allows anything with hello, comma, and then a string. This is super useful for things like units, where you can accept any number plus the unit itself. This is really powerful. Number formats have also been added to Zod, like int, float, uint, and they already have their proper max-min value constraints. There's even support for big ints too. This comes with a change where int only accepts safe integers, and positive infinity and negative infinity are no longer considered valid values for z.number. The file method is a long overdue one. You can now validate file instances for things like size and type. Stringball is a nice developer experience update. It allows you to do EMV style Boolean coercion, so passing values like true, on, yes, 1 to true or false. Even lets you define your own truthy and falsy values. Next up, a new way to define objects, z.interface. It's almost the exact same as z.object. The difference is it has exacter optional properties. To explain, in TypeScript, a property can be optional in 2 ways. In key optional, the key itself is optional and isn't needed on the object. In value optional, the key is needed, but the value can be a string or undefined. Zod 3 wasn't actually able to do value optional, so a new API was needed. Z.interface will allow you to do both key and value optional, with key optionality being done by adding a question mark to the key. An amazing side benefit of this change is that Z.interface can be recursive. In Zod 3, to have a type reference itself, you'd have to define a redundant interface, use z.lazy to avoid reference errors, and then cast your schema to Zod type. In Zod 4, you can use interface and getters to define any cyclical properties. This is going to be great for cyclical data structures like those seen in ORM schemas or GraphQL types. They do note here though that object will never be deprecated or removed, but due to the benefits that I just mentioned, they recommend using interface over object. A few other types got an upgrade. For discriminated unions, you no longer need to specify the discriminator itself. Zod can actually identify this automatically. Discriminated unions also finally compose as well, so you can use one discriminated union as a member of another. Z.literal got a small change, allowing you to use multiple values. That's a nice developer experience change, but an even better one is refinements now live inside schemas. This is extremely useful as it means you can use schema methods on refinements like max, min, and everything else. This change has also allowed the addition of a new overwrite method for representing transforms that don't change the inferred type. Unlike .transform, this method returns an instance of the original class, so in this case it retains the Zod number type. They've even updated .trim to lowercase and to uppercase to implement overwrite already. Z.email now accepts custom regex, and the library actually provides a few as well. Note that I didn't actually need z.string.email there. We'll talk about that in a bit. Now, Zod actually uses Gmail's rules for email validation at the moment. You can use HTML5's rules, RFC 5322, or Elusa regex for Unicode email. If you've never had to deal with email regex, consider yourself lucky. This is what's currently in Zod. Talking about string types, string formats have been moved to the top level, so you no longer need to do z.string.email, you just do z.email. This is only a deprecation though, so nothing will break immediately if you use the older methods. What has been removed though is .ip and .cidr. These have been replaced by more specific .ipv4 and .ipv6 methods. Another big upgrade for Zod is first-party JSON schema conversion via the z.toJSONSchema method. Any metadata in the z.global registry is automatically included in the JSON schema output, like this example. But wait, what is the global registry? Well, Zod has added a new system for adding strongly typed metadata to your schemas. Metadata isn't stored inside the schema itself. Instead, it's stored in a schema registry that associates a schema with some typed metadata. The global registry accepts some common JSON schema compatible metadata, which you can add to like this, or more conveniently use the .meta method. This is similar to how described worked before, but meta is now preferred. You don't have to use the global one all the time. You can actually create your own registries and add schemas to it or get values. Now let's talk errors and then breaking changes, as most of them actually involve the way errors are handled. This one is massive for me. Zod has simplified error customization. Long story short, there is now a single unified error parameter for customizing errors, replacing the other APIs like message, which is now deprecated, and invalid type error, required error, even error map have all been removed. Something else cool with errors is there's now a pretty error method to take in this mess of a Zod error and print it like this. That is way nicer. Plus, for the international folks, Zod is adding a locales API for globally translating error messages into different languages. At the moment, English is the only supported language, but they're looking for help to fix this. So that's some of the shiny new changes and a few of the deprecations, but is migration going to be easy? Well, if you take a quick look down the migration guide, you'll see there is tons in here. I'll pick out some more notable ones that I might have missed. First, Zod error no longer extends error, so you may have to modify some of your error handling. Format and flatten have been deprecated in favor of z.treeify error. .form error has been dropped as it was basically identical to flatten, and add issue and add issue methods are deprecated in favor of just pushing to the array. There's been a bunch of object changes. The strict and pass-through methods have been deprecated for top-level methods like strict object and loose object, with the same methods being there for interfaces. Non-strict and deep partial have been removed. Deep partial was largely an anti-pattern and had a lot of footguns. The same applies for the promise method, which has also been deprecated. Just use and await before you do anything. Now, for more advanced use cases, there is a few more changes you might want to check out, so I'll leave a link below to the migration guide. That is a huge update, and I didn't even mention that it's faster on several benchmarks. It'll be in beta for around 6 weeks, so adopters and libraries have a chance to implement this. Overall, it seems like a great update that cleans up some long-standing issues and allows for extensibility into the future. The future of Zod really does look bright. Let me know what your favorite addition was in the comments down below. While you're there, subscribe, and as always, see you in the next one.